All right, guys, this is Unit 12. We'll see how long this unit lasts. I'm not too sure how many lessons there'll be in this unit. I think it might be a little shorter than usual, but we'll see. We'll see. All right, so we're going to be introducing you guys to what's called analytical geometry. Basically, it involves a lot of things like solving equations, but also using these things called identities to do a variety of things. So we'll look at it and you'll see it as we go. So today I'm going to be introducing you guys to these things called identities, and we're going to be using those to simplify expressions and also to verify other identities. So in other words, verify means to prove things are true. So I'm going to teach you about identities, and you can use them to simplify and to prove things. And that's what we're going to be doing in this lesson. So let's begin. So first of all, what is an identity? An identity is an expression that is equivalent to, or in other words, identical to, hence identity, equivalent to or identical to another expression. So for instance, 2 times x minus 1 is equivalent to, or is an identity of, 2x minus 2. If you just distribute the 2, you get this thing, right? And so those things are identical. So that would be an example of simplification. So as you guys can see, this identical expression, this identity, is a simpler version of this expression over here. You can also use them to solve, though. So, I guess I put another factoring one up here. You can use factoring to find identities, too. So like if you have this, if you factor it, you get something like this. And the factoring is very helpful when it comes to solving. So as you guys can see, identities can be used for solving as well. So they are used to simplify and to solve. So here's an example of simplification. If you have x squared plus 2x plus 1 over x plus 1, you could factor the top and reduce and end up with a simpler expression. Okay, so we have two expressions that are, for the most part, equivalent, so they're identities of each other, but one is simpler. You can also use it for solving, as I mentioned. So if you had x squared plus 2x plus 1, you could rewrite it as x plus 1 squared to solve. Okay, and so like I said already multiple times, identities or rewriting algebraic expressions in a different way can help you simplify or solve. Okay, so now we're talking about trigonometric identities in this chapter, though. And so what are some trigonometric identities? Well, sine x is identical to 1 over cosecant, or cosecant is identical to 1 over sine. We've already learned these, actually. Cosine is identical to 1 over secant, and secant is identical to 1 over cosine. Tangent is identical to 1 over cotangent, and cotangent is identical to 1 over tangent. These are called the reciprocal identities. Now, just so you guys know, in this chapter, we won't be using these at all. In fact, I don't think we'll probably be using this one either. We might be using these two a whole lot. I don't think we'll even be using this a whole lot, but they are true statements, so they are trigonometric identities. But we're going to make most use of these guys here, just so you know. All right, let's go ahead and move on and take a look at some other types of identities called the quotient identities. And I'll prove this on the next slide, but tangent is actually identical to sine over cosine. And since cotangent is the reciprocal of tangent, cotangent is cosine over sine. These are called quotient identities, and we will be using these a lot. So keep those in mind. So let's prove to you that tangent is equal to sine over cosine. Now, you guys may recall that on the unit circle, every point has an x value and a y value. You may also recall that sine is equal to the y value and cosine is equal to the x value, right? Now you may also recall that in SOHCAHTOA, tangent is opposite over adjacent, right? So if this is my angle, this is my opposite side, this is my adjacent, which just so happens to be y and x. And since y, so basically tangent is opposite over adjacent, which means that it's y over x. And since y is equal to sine and x is equal to cosine, well, that basically means that tangent is sine over cosine. Okay? And you could do something similar to show that cotangent is cosine over sine, right? So that's the quotient identities and where they come from, all right? So now let's go ahead and actually start putting these things to use. Today we're going to be just using the identities to simplify expressions and prove that one side is equal to the other. So for instance, I'm going to simplify the left side over here, and in the process of doing that, we're going to prove that it actually equals this right side. And that's called verifying or proving an identity. Okay, so we're going to be using the identities I shared with you to prove that this identity is also true. Okay, so that's it. Now we're going to use 3 strategies today for verifying or proving identities are equal. One of them is this, changing everything into sine and cosine. That's one of our strategies. Another strategy is simplifying complex fractions. We're going to be doing that as well. And a final and third strategy is we're going to be combining fractions. Now, that's all just mumbo jumbo to you right now, but you'll see what they are when we get there. Let's go ahead and start with strategy 1, changing everything into sine and cosine. So, here we go. First of all, I want you guys to recognize when that's written like that, secant squared x, what that really means is you're squaring secant x. So I'm going to rewrite it like this, and I would encourage you guys to do the same. Okay, so there's that. Now, we need to change everything that's not sine or cosine into sine or cosine. So let's take a look at this. Let's start on the right side. Cosecant x. How can I rewrite that? Well, let's go to our identities. Over here, we see that cosecant of x is 1 over sine. So that way I can rewrite cosecant as 1 over sine. So that's what I'm going to do. I'm going to change cosecant into 1 over sine of x. All right? Now this one's okay. I want to leave that one alone because it's already cosine. We like cosine and we like sine. We don't want anything else. And I'm going to go ahead and put this over 1 since everything else is a fraction here. All right, but this is not okay. We don't want cotangent. So let's rewrite that. So why don't you guys look at the list of identities that you've written down today and see where does it say that cotangent is equal to something with a sine and a cosine in it? Take a look and see if you guys can find it. If you guys look at this slide here, you can see that cotangent is actually equal to cosine over sine. And that's the one that we're going to use. So I'm going to replace cotangent with cosine x over sine x, just like that. All right, one more here. We need to change the secant of x into a sine or a cosine. So look at your charts and see what you can change those into. Secant of x is 1 over cosine. Okay, so that's the main strategy. We're not done yet. I haven't proven that these two sides are equal, but that's the main strategy I want you guys to be aware of, is change everything into sine and cosine. All right? After that, it really is just a matter of simplification. All right, so I'm going to square this fraction here by squaring 1. 1 to the second power is 1. And then I'm going to square the bottom, which is cosine squared. So there's that. Then we have cosine x, sine x, cosine x over 1, and then 1 over sine x. Okay, the next thing I'm going to do is I'm going to multiply all my numerators together. So if I do 1 times cosine, what would that come out to be? If I multiply all those numerators together, what would that come out to be? Well, putting all 3 of those together, you would end up with cosine of x squared. What if I multiply all of these denominators together? That's going to be cosine of x squared times sine of x And you don't really need to include the 1, because when you multiply by 1, it's just 1, right? Okay, now what do I do? Well, what else can I do to simplify this? Well, you guys may notice that there's a cosine x squared on the top and bottom, and those reduce. So they cancel each other out, and I'm left with this. Now, as soon as you get the two sides to be equal to each other, in other words, they look exactly the same, you're done. You've proven it. We have proven that this side is equal to this side. So what were my steps? What did I do to solve this problem? And so here's the steps. Rewrite everything as sine and cosine using the identities. Simplify it as much as possible. Your goal is achieved when both sides look the same. So I'm going to let you guys practice a problem like that following those steps. Let me jump up to it, student practice. And I'm going to have you guys work on number 1. So go ahead and pause the video here and work out number 1 and see if you guys can get this side to equal this side using the identities. When you unpause the video, I'll have the steps revealed for you. Okay guys, so here's the steps. Step 1, changing everything into sine and cosine. The tangent becomes sine over cosine. I just made cosine squared x look like this, cosine of x squared over 1. And then secant x, I rewrote that as 1 over cosine, and sine is fine the way it is. All right? And then I multiplied all my numerators together and all my denominators together, and I got this purple expression here. And then finally these simplify away, and I'm left with sine x equals sine x, and since both sides look the same, I am done. I have proven that this side is equal to this side by using my identities. So let's go ahead and move on to our second strategy, which is simplifying complex fractions. So for these types of problems, the first thing we're going to do is the same thing we did in the last one. We're just going to change all of these expressions here into sine and cosine. So here we go. Cosecant, you can rewrite that as 1 over sine of x. The 1, I'm just going to leave that as a 1. Cosecant squared, remember I like to think of that as cosecant of x squared. So that really means I have 1 over sine of x squared. Okay, so there's that. That's still going to be the next step. Now for my next step, I'm going to do a couple of things. I'm not going to record it as a step because you may have to do things like this sometimes and sometimes you don't. But I'm going to distribute here on the right side of the equation. So that's going to be sine of x squared plus sine of x. So if you just multiply that sine of x into the parentheses, you get sine of x squared plus sine of x. On this side also, I'm going to square the top and the bottom. And so of that fraction there on the bottom side, that gives me the following: 1 over sine x plus 1 over sine of x squared. Okay, now after that, we're going to simplify this side over here, this complex fraction, by multiplying by these little denominators. We've simplified complex fractions before in this class. We don't like having these little denominators here. And so we're going to get rid of them by multiplying everything in the expression by those values. Now, sometimes you'll have to do it twice. Like you might have to do it by sine x, and you have to do it again by sine squared x. But sometimes you can cancel everything out if you just pick the right thing to multiply by. Usually if you multiply by the bigger thing, more stuff cancels out. So I'm going to actually multiply by sine of x squared because that's bigger than sine of x. All right, so we're going to simplify the complex fraction by multiplying the denominators. So I'm going to multiply this fraction here by sine of x squared. And the benefit of that now is that this is going to cancel this out, leaving me with only a 1 on the bottom now. But whatever you do the bottom of this big old fraction, you got to do the top. So I'm going to multiply by sine of x squared here. And I'm also going to multiply by sine of x squared here. Okay, so now right here, 1 times sine of x squared is just going to be sine of x squared. That's pretty simple. And then here, Sine of x squared over sine of x. Well, you could think of that as sine of x squared. That means sine of x times sine of x, right? If you have sine of x squared. So you have sine of x over times sine of x over sine of x. So they cancel and they leave you with just one sine. So this simplifies to be just sine of x. Okay? And as you guys can imagine, we don't really need the 1 on the bottom here. And we're pretty much done. These are identical. They're just in a different order. So we could just kind of go ahead and do one more step here just to finalize it. I could switch the order of these, because with addition, it doesn't really matter what order they're in. And we don't really need the bottom number anymore, right? And now, as you guys can see, the right side of the equation is identical to the left side of the equation. So how did we solve this one? We changed everything into sine and cosine, and we simplified the complex fraction by multiplying everything by the little denominators. And that's it. You just have to do those two things and make sure you simplify as much as possible, and you'll land where you need to. So let's go ahead and throw one of those at you guys. Let's go ahead and take a look at number 2. Let's go ahead and do number 2. All right, so we'll do this in baby steps because it's a little bit harder. Why don't you guys go ahead and pause the video here and see if you could do the first step. Just change everything into sine and cosine if it's not already sine or cosine. When you unpause the video, I'll have that step displayed for you. All right, so there you go. That's the first step. Secant becomes 1 over cosine, and you have that here and here. All right, now we're ready for the second step. We want to get rid of the cosine x here and here, and the way you do that is by multiplying everything. You're going to multiply this, and this by cosine of x. So go ahead and give that a try. Pause the video. When you unpause it, you will see the outcome of that. And once again, we have, as a result of multiplying here, here, and here by cosine, we end up with this. And now look, the two sides are identical, and we're done. We've done our proof. All right, let me give you another one like that to try really quick. Go ahead and pause the video here and try number 4, but this time, see if you could do the whole thing on your own without me walking you through it. And when you unpause the video, I'll have all the steps written up there for you. All right, so I broke this up into 4 steps. Now really, there's 2 main steps in this, but there's some little sub-steps I included here. So you may not have shown every step like I did, but it doesn't matter. So the first step I did was I don't like the way they've written this. I like to rewrite it where it's secant of x squared. So that's the first thing I did, was I changed all of these to look like that. The next thing I did was I did the real important step, which is to change everything to sine and cosine. So secant becomes 1 over cosine, and cosecant becomes 1 over sine. The next thing I did was I applied the power here to both the numerator and denominator. So that separates them. So that looks like this in step 3. And then after that, we get to the other big main step, which is to multiply by the denominators. So in this case, you would multiply cosine x squared on the top and the bottom of this fraction, which would look like this. And on this one here, you'd multiply the top and the bottom by sine of x squared, and that would look like this. And after you simplify these cancel, and you're left with 1 on the top. Same thing here, these cancel, 1 on the top. And now on the bottom, on both sides, you have cosine x squared and sine x squared. And at that point, they're identical, so we are done. All right, I've got one more strategy to share with you guys before we call it a day. Combining fractions. So let's review really quick. We've talked about 3 strategies. Strategy 1, change everything to sine and cosine. Strategy 2, if you ever end up with a complex fraction, simplify it by multiplying by the denominators. Strategy 3, sometimes you may have to combine fractions together, and that's this last thing that we're going to talk about. So you're still going to do that same first step on every problem. You're still going to change everything into sine and cosine. So let's do that. So step 1, change everything to sin or cos. The only thing that's not sin or cos here is this guy. So we're going to change that into 1 over sine of x. Now, since there's a fraction for one of them, I'll make the other one a fraction as well. And so now this is where we get to the other major step now, which is we want to be able to combine these two fractions together. But in order to do that, how do you combine two fractions? Well, you get them to have a common denominator. All right, so what's the common denominator for sine and 1? That's kind of weird. Well, it's pretty simple. Just multiply this fraction by 1 on the top and bottom, which really won't do anything. But on this side, multiply this fraction by sine on the top and bottom. And that way they'll end up having a common denominator. So the end result will be 1 over sine x plus sine x times sine x is sine x squared, right? I haven't done anything on this side yet. And that's perfectly fine. All right. And after that, we're ready. We're still on step 2, though. We need to now combine the fractions together. Now that we got them to have a common denominator, now we can actually go ahead and combine them together. So you just take 1 and add it to that one there. So you have 1 plus sine x squared over the common denominator. And the right side looks like this. And as you can see, we're basically done at this point, right? The only thing that's different is the way I've written my square, but that doesn't matter. These are identical, so we're good. All right, and that's it. So change everything into sine and cosine, and if you ever have two fractions that are being added to each other, we'll go ahead and combine them by getting a common denominator. So let's see if you guys can go ahead and try one like that. Try doing number 3 here. So go ahead and pause the video and give number 3 a try. And when you unpause it, I will have the problem all worked out for you. Okay, so here's the solution of that. The first thing I did was I changed it so that the squares look like this instead, because that's how I like to write them, as I've mentioned before. The next thing I did was I changed the secant x into 1 over cosine of x. The next thing I did was I distributed this power here to apply to the top and bottom separately, and so I got this as a result. After that, we got a common denominator, so I multiplied the top and the bottom by cosine of x squared on this side and 1 on this side, and the result was this expression here. After that, since we have our common denominators, we can just add the numerators together and get this. And we end up with the two expressions being identical at that point. And so we're done. And so there it is. So today we talked about what an identity is. It's two expressions that are equivalent to each other. And why do we use them? We use them because they're helpful for simplification and for solving. And we talked about the reciprocal identities and the quotient identities. And we use those to prove some statements were equal today, using 3 strategies: changing everything into sine and cosine, using our identities, simplifying complex fractions, and combining fractions together. And so that's it. So here's a summary of our strategies here that we've learned today, and we'll probably add a little bit more to those as we go on throughout the process. So that's it for today. Hopefully that was helpful, and we'll see you guys in class.